Welcome back. I am Anas here. Now I am going to discuss the IIT JAM problem and solutions. The previous year IIT JAM's questions and answers regarding the shape of the molecules. So today I will discuss two questions and their answer. Let's go to the problem. Here, first problem is which of the following has square planar geometry according to the VSEPR theory? Out of the four options, which of the molecules has square planar geometry? This is the questions. These questions came in IIT JAM questions 2010. This is one more questions. Again, I repeat the questions. Which of the following has square planar geometry according to the VSEPR theory? And the spaces given are in the option A, XCO2F2, option B, XCF4, option C, SF4, and option D is PF4 minus. These are the four spaces which are given in the questions. We have to calculate their bond pair electrons and lone pair electrons and then determine the shape of the molecules. Let us start the solution of these questions. This is very easy. I gave the track in the previous videos to calculate how to calculate the shape of the molecules. The first option here is XCO2F2. There are two central atoms. There are xenon and oxygen, and there are fluorine. So we have to calculate the valence electron of all the four atoms. Here we all know the valence electron of xenon is 8, and there are the valence electron of oxygen is 6. There are two oxygen atoms, so 2 into 6, and there are the 7 valence electron in the fluorine atom. So there are 2 fluorine atoms, 7 into 2. Here total valence electron, here I write down 34. Total valence electron here is 34. So I divide, 34 is greater than 8, so I divide it by 8. 8 into 34. 34 is divided by 8, so 8 into 4 is equal to 32. Here remainder is 32. Again there are remainder is 2. So again I divide it by 2. So quotient is 1 and remainder is 2. And here total remainder is 0. So there are 4 bond pair electrons and 1 lone pair electrons. So according to our tricks, I remind the tricks. Here, this is the tricks. I share these tricks in the previous video. Again, I repeat the tricks. Here, types of molecules, number of bond pair electron, number of lone pair electrons, and type of hybridization. The 8 numbers type molecules here I given. AB4L means 4 bond pair electron, 1 lone pair electron, and the geometry is seesaw. The geometry is seesaw. In our questions, here I gave there are 4 bond pair electrons and 1 lone pair electron. So this is shape is seesaw shape. But in the questions, asking that the square planar geometry or square planar shape. Again, the option 1 is wrong answer. Second, we have to go option B. Option B said that the molecule is XCF4, here xenon tetrafluoride. We all know there are 8 valence electrons in the xenon atom. So I write down 8. There are 4 fluorine atoms, and 1 fluorine atom contains 7 valence electrons. There are 7 into 4. Total valence electron is equal to 36. So I divide 36 by 8. Here 4 is the quotient. 4 is the bond pair electrons. 8 into 4 is equal to 32. So 36 minus 32 is equal to 4. Again, I divide 4 by 2. So 2 into 2 is equal to 4. Here 2 is the quotient and remainder is the 0. So first quotient is the bond pair electrons. Second quotient is the lone pair electrons. Again, I want to repeat. Here second option is xenon tetrafluoride. Valence electron is 8, and here 7 into 4. Fluorine has 7 valence electrons. 7 into 4. Total is equal to 36. So 36 is greater than 8, so it is, I divide it by 8. 8 into 4, 4 is the question, is the number of bond pair electrons. Here 36 minus 32 is equal to 4. Again I divide 4 by 2, so 2 is the question, that is lone pair electrons, are remainder is 0. The number of bond pair is 4, number of lone pair is 2, so 4 is 2. This is square planar geometry. Again I want to see the tricks. Let's test tune. Please see here, Av4L2 type of molecules. Here 4 is the bond pair electrons, 2 is the lone pair electrons. Hybridization is the sp3d2 or d2sp3. Geometry is square planar. So we have here also in Xe4 type of molecules there are 4 bond pair and 2 lone pair. The geometry is square planar. So this is the B option is the correct option. B is the correct option. Here Xe4, 4 is the bond pair, 2 is the lone pair. So B is the correct option. Here Xe4 is the answer. B option is the correct. Again, there are two other species there, SA4 and BF4 minus. I also discuss about the shape of these molecules here. In the C option, SA4 molecules, though we all know there are 6 valence electrons in the sulfur atom. So I write down 6. There are 7 valence electrons in the fluorine atom. So 7 to 4 is equal to 34. So 34 is greater than 8. So I divide it by 8. So 4 is the quotient. And here is 32. So 34 minus 32 is equal to 2. Again I divide 2 by 2. So here question is 1. Remainder is 0. So 4 is the bond pair electrons. 1 is the lone pair electrons. The SA4 I already discussed these questions in the previous video. So here SA4 is the 4 bond pair, 1 lone pair. So its geometry is TBP, trigonal bipyramidal, and the shape is seesaw shape. This is the structure of SA4. So SA4 is also wrong answer. Option D said BF4 minus. So BF4 minus, there are 3 valence electron of boron. Boron has 3 valence electron. So there are 7 valence electron is fluorine. So 7 into 4 plus 3. There are a negative charge. So there are extra electrons. So I add 1. The total valence electron is equal to 32. So again I divide by 8. The question is 4. Here 32. 32 minus 32 is equal to 0. The total number of bond pair electrons in this species is 4. So there are no lone pair electrons, so it is tetrahedral geometry, tetrahedral shape. So in these questions, the answer is option B is Xe4, because Xe4 have square planar geometry, 4 number of bond pair electrons and 2 number of lone pair electrons. The second questions. Here the second question is, please write down these questions in your notes. This is very important. This type of questions came in IIT examinations and also all other competitive examinations. This question came in 2007. Here the question is the shape of CH3 minus ion is. CH3 minus ion, what is the shape of this ion or this species? Here the option are, first option is trigonal planar, second option is tetrahedral, third option is trigonal pyramidal, fourth option is linear. So here the solution, there are how many valence electrons? We have to calculate how many valence electrons are there in CH3 minus ion. So here we all know the number of valence electrons present in carbon. There are 4 valence electrons present in carbon. Again there are 3 hydrogen atoms. So I write down here there 3 number of hydrogen atoms, and there are number of valence electrons present in hydrogen atom is 1. So 3 into 1 is equal to 3. There are negative charge, so I write down 1. So total number of valence electrons is equal to 8. According to our tricks, to calculate the number of bond pair lone pair electrons, if it is equal or less than 8, so we should divide it by 2. So here I divide it by 2. So 2, here 4 is the quotient and 8. So 2 into 4 is equal to 8. Mistakenly write down 4. So this is 8. 2 into 4 is equal to 8. Here, so 2 into 4 is equal to 8. So 8 minus 8 is equal to 0. So here 4 is the bond pair electrons. If there are 4 is the bond pair electron, means there are 4 bonds present in the molecule. But here in the CH3 minus ion, there are only 3 side atoms, though there are only 3 bonds should be. So there are no 4 bonds possible because hydrogen has 1 valency electron. So hydrogen cannot form a double bond with other species, other molecules or other atoms. So this is wrong. So we have to divide it by 2, and we have to quotient less than that 4. So there I take the quotient 3. So 2 into 3 is equal to 6. Means there are 3 bond pair electrons. And here this remainder is 2. Again I divide 2 by 2. 2 into 1 is equal to 2. So remainder is 0. There are 1 lone pair electron, 3 bond pair electrons. In this case, you have to manage your memory, your capacity to learn about chemical bonding. You have to memorize these things. You have to handle these things technically. Here is 3 side atoms, so there cannot be possible 4 bonds because hydrogen have only 1 valence electron. In this case, I divide it by 2, but take the quotient is 3. Again, according to this, there are 3 bond pair electrons, 1 lone pair electrons. This is the sp3 hybridations, and the geometry is trigonal pyramidal. Sorry, geometry is tetrahedral. Here, there are 3 bond pair, 1 lone pair. This is the ammonia types of molecules, NH4 plus. This is the ammonia NH3 molecules. NH3 have this type of geometry and this type of shape. NH3 has also trigonal pyramidal shape. This is also trigonal pyramidal shape. So this is the trigonal pyramidal shape. The answer option is option C is the correct option of these questions. Correct answer. The shape of CH3 minus ion is trigonal pyramidal. This is all about the chemical bonding. If you enjoy my video, if you are getting tricks, ideas to solve all the problems and solution, then please see my all videos and subscribe my channels, and also give your important suggestion in the comment box. Thank you.